Thank you for joining this lesson. We're going to look at gas laws again. We are told air is trapped in a thin capillary tube by a thread of mercury 5 centimeters long, as shown in the figure below. So we have a thread of mercury 5 centimeters long. Then the air which has been trapped is having a column of 14 centimeters. Then we can see when the tube is inverted, the column becomes 16. The column is increasing. Then we have the mercury thread, which is still 5 centimeters. Use the information in the figure to calculate the value of the atmospheric pressure in millimeters of mercury. In millimeters of mercury. So this is an application of Boyle's law. Boyle's law, which says that pressure is inversely proportional to volume, and that's why in the first case, we should say that let me deal with the equation first. Constant out of volume. That means to get a constant, we need pressure times volume, and when we vary pressure and volume to get a different value of pressure and a corresponding volume, you discover that the constant they give us is still the same as the first values gave. That means we need to know that pressure 1 and volume 1 should give us pressure 2 and volume 2. It's just the same. So this is the equation that will govern our calculation. But now when we come to the application, in this case, you discover in the first case, if we talk of pressure 1, the pressure acting on the column of air is equals to the unknown atmospheric pressure, because it is open here, the unknown atmospheric pressure plus pressure due to this mercury thread, which is 5 centimeters. So if we can give these ones as centimeters of mercury, then we can talk about volume 1. Now that the volumes have not been given as capacities, then we can talk of the column of air to represent volume, because the greater the column, the greater the volume, and the smaller a column is, then the smaller the volume, as long as the glass tube is having a uniform cross section. Then this length can represent volume. So 14 centimeters. In the second case, the second volume now, when it has been inverted, equals to 16 centimeters. In this case, pressure 2 is going to be, remember, due to the opening, atmospheric pressure is acting there. The value is x, still unknown. But in this case, the weight of the mercury thread now is acting downwards. Therefore, the resultant pressure is the one which will be acting on the air. And that is, atmospheric is greater, so we subtract 5. Then the resulting pressure in centimeters of mercury is the one to be acting on the column. It is the one to be acting on the column. Therefore, now we can apply here pressure 1, volume 1, pressure 2, volume 1. It's the same. Therefore, x plus 5 multiplied by 14 should be the same as 16 multiplied by x minus 5. Then now we can get x. This is going to be 14x plus 14 by 5. This is giving us 70 equals to 16x minus 16 by 5, giving us 80. Therefore, we can group like terms whereby 14x to this side will be 2x. Then 80 to this side will be 150. Yeah, 150. So that means we can now have x as 75 centimeters of mercury. That is the pressure of atmosphere. But now it can be converted to the said units here, millimeters of mercury. This will be 750 millimeters of mercury. 750 millimeters of mercury. So that is the pressure. In another case, whereby instead of having the tube inverted, Sometimes it is made to lie horizontal, such that we have it like this. The mercury thread is still here, 5 centimeters. Yeah, 5 centimeters like that. Now in this case, the pressure is going to be strictly pressure due to atmosphere, because the weight of this mercury thread is acting downwards at this point, and therefore not compressing the air, not compressing this air. Therefore, it is only atmospheric pressure working on the air. Therefore, for this case, when it is upright, it is the mercury thread plus atmospheric. When upside down, because the column of mercury thread is acting downwards, atmospheric is entering, it will be the resultant pressure and hence a subtraction. But in a situation whereby it is laying horizontal, then you're going to deal with pressure, in this case being strictly pressure due to atmosphere. Therefore, if we were handling such a case, we could have said pressure is strictly the value of X. So that is what could have happened. Thank you for following. Subscribe and share this link.